Welcome to this tutorial on converting documents using Python. In this tutorial, you will learn how to implement a PyCharm project that utilizes Python code to create a Py6-based window. This window allows users to select a raw text file and convert it into various document types. To get started, please click on the item highlighted inside the yellow rectangle. Name the project as shown here in the image. Once done, click on the Create button to proceed. We need to install the packages shown in the pip command because they are essential for our project. These packages include Py6, which is required for creating a window-based application, and others like pandas for data manipulation. Follow the highlighted command in the terminal to install them. To create your first Python file, start by right-clicking on the projects folder in the PyCharm interface. Select Python file from the drop-down menu that appears. Type in the name highlighted inside the yellow rectangle and press Enter to create the new file. The code provided imports necessary standard and third-party libraries. It includes operating system manipulation with OS and sys, regular expressions with re, data handling with pandas, and partial function application with functools.partial. Py6.qt widgets provides various components for building the GUI, such as buttons and labels, and Py6.qcore contains core functionality like signals and threading. The highlighted code defines a function named detectASCII-table. This function is designed to identify and parse ASCII tables present within given text lines, returning both a data frame and the updated list of text lines. Make sure to type this code correctly if you are following along. The highlighted code is part of the detectASCII-table function. It utilizes a regular expression pattern to detect ASCII tables within a text. It initializes a list for the table content, a copy of the text lines, and table positions to record them. If you are following the steps, ensure you type this code as well. The highlighted section processes the full text by joining all lines together and appending a new line at the end. It iterates over every match found using the table pattern, recording the start and end line of each match. These positions are stored in the table positions list. If you are following this tutorial, please type this code as shown. This loop iterates over the table positions, each represented by a start and end position. For each position, it captures the relevant text lines, allowing the function to separately process the text contained within each detected ASCII table. The highlighted code iterates over the start and end positions of ASCII tables found in the text, as stored in table positions. For each table's start and end, it captures the related text lines for further processing. The highlighted section in the screenshot shows a try except exception as E block in a Python script. The try except block is used for handling exceptions in Python. Code that may raise an exception is placed inside the try block, and the except block catches the exception and allows you to handle it, preventing the program from crashing. Type the following code as shown in the highlighted area. The highlighted code locates a block of text, formatted like a markdown table, parses its header and rows into a structured pandas data frame, stores it in table content, and then replaces the original text block with a table placeholder for further processing. This snippet is almost always found inside an except block and does two things. The leading F makes it an F string, so start, end, and E are replaced with their current values. For the continue, immediately abandons the rest of the current loop cycle and jumps back to the top for the next set of lines. This ensures that one bad table doesn't crash your entire parsing loop. In plain terms, if parsing a block of lines fails, this code prints exactly where and why it failed, then quietly moves on to try parsing whatever comes next. This line returns the table content as a list of data frames and the updated list of lines with table placeholders, concluding the detectASCII-table function. This line defines a new function detectHeadings, which takes a list of text lines as input. Its purpose is to classify each line as a heading, paragraph, or table placeholder. The highlighted code initializes a list to store the classification of lines. It loops through each line, checks its type, heading, paragraph, or table, and appends a tuple with this information to the result list. In this section, each line is stripped of whitespace. Lines identified as table are marked as table. Lines with specific patterns, such as those followed by a line of dashes or consisting of fewer than 10 words starting with a capital letter, are marked as heading. Otherwise, they're considered paragraphs. This return statement provides the final processed list of line classifications, marking each as a heading, paragraph, or table reference. This code snippet defines a function called loadDocument that takes a file path as an argument. It is used to load the content of a document based on its file extension. The code retrieves and converts the file extension to lowercase, allowing the function to process the file accordingly. If the file extension is txt, the code reads the text file, stripping new line characters. It then detects ASCII tables and headings, returning the tables and tagged content information. In the case of CSV files, the code uses pandas to read the CSV file while skipping bad lines. It returns the data as a table, indicating that a table is present. For Excel files with .xls or XLSX extensions, the code reads the content using pandas and returns it as a table. The .html extension triggers the code to read the HTML file's first table using pandas, returning it as a data frame. If the file is a .docx document, it imports the docx library and reads the file. It extracts tables and paragraphs, storing them in a data frame or list respectively. For PPTX files, the code imports Python PPTX to extract tables and text content from slides, returning this data as tables or paragraphs. If the file extension is unknown or unsupported, the code raises a value error, indicating that the file type is unsupported. The code introduces the function convert to PDF, which will handle the conversion of data into a PDF format. This line imports the FPDF class from the FPDF library. The FPDF library is used for generating PDF documents through Python. By importing FPDF, you can create and manipulate PDF files in your script. The highlighted code, class PDF, defines a class named PDF that inherits from a base class also named PDF. This is typically done to extend or modify the behavior of the base class within the new PDF class. The init method initializes the PDF class with a title. It calls the superclass initializer and sets the instance's title attribute to the provided title. The header method sets the font and adds a header to the PDF using the title. It centers the title text and moves the cursor down 10 units for spacing. The footer method sets the position at the bottom of the page, sets the font, and adds a centered footer with the current page number. It uses a placeholder for the total number of pages. This code snippet initializes the PDF object with a title derived from the file path, adds a new page, and sets the font to Helvetica with size 12. This snippet initializes the table index and begins iterating over the content to process each item based on its type. If the content item is a table, this code retrieves the corresponding data frame and calculates the column width. It then formats the headings and content, adding them to the PDF, and increments the table index. If the content item is a heading, this code sets a bold font for the heading, adds it to the PDF left aligned, and adjusts the font back to normal after adding a line break. If the content item is neither a table nor a heading, this code uses a multi-cell to add it to the PDF, followed by a line break. This line generates the PDF file at the specified path, saving all the content and formatting applied. The convert to HTML function writes HTML content to a specified path. It styles the document, converts tables using data frames to HTML method, and formats headings and paragraphs accordingly. This function, convert to Excel, takes structured data and a file path as input. It converts the data into an Excel file using tables if available, or otherwise plain text content. The resulting Excel file is saved at the provided path. This function, convert to Word, converts structured data into a Word document. It processes tables, headings, and regular text, adding them to the document. The document's header and footer are customized to include the document title and page numbers. The final document is saved at the specified path. The function convert to PowerPoint creates a PowerPoint presentation from structured data. It loops through the content, adding slides with titles, tables, or text boxes according to the item type. Tables are formatted from data frame objects. The presentation is saved at the given file path. The converter's dictionary maps document types to their respective file extensions and conversion functions. It allows dynamic selection of the conversion process based on the desired output type. This class conversion thread extends QThread and handles the document conversion in a separate thread. It emits progress updates and a finish signal with a status message. It supports error handling to indicate conversion failures. The main window class is a GUI application window for the document converter. It initializes the user interface, allowing users to select a file, an output directory, and the types of documents to convert. It starts the conversion process when prompted by the user. This method, select file, opens a file dialog for the user to select a document. If a valid file is chosen, its path is displayed in the file edit line for processing. The method select output opens a directory selection dialog. The chosen directory is then set as the output location for converted documents, displayed in the output edit line. This method, start conversions, validates the selected file and output directory. It initializes progress bars and threads for each selected conversion type. Conversion threads are started and their progress and completion are tracked in the UI. This code block initializes the Qt application. It creates and displays the main window, setting up the application loop, which waits for user interactions until the program is exited. Right-click inside the name block and choose Run to test the setup. The first button is used to select the raw text document for conversion to PDF, HTML, Excel, Word, PowerPoint, or any combination thereof. Click on it. This is the sample document to convert. Right-click on the file and choose Edit to preview it. Click on Edit. The code implemented can detect tables in the raw text document, converting them and utilizing each file format's table styling abilities. Close the sample document. Click on Open. The next button selects the output folder for the converted files. Click on it. Click on the highlighted button. Check PDF, HTML, Word, and PowerPoint. We'll test Excel with a CSV file later. Click on the Start Conversions button. Review the highlighted area showing that all selected file formats were successfully converted, indicated by the 100% completion status for each. This step displays the converted documents. The HTML document is inside the sample document.html tab, which is not visible in the image but can be checked. Notice that the code effectively detected tables and styled them according to each file format's capabilities. After clicking on the sample document.html tab, you can view the HTML document. Next, we will test converting a CSV file to Excel. We will now work with a different sample file containing CSV content, specifically a CSV file. Our goal is to convert this file to an Excel format for testing purposes. Select the CSV file for conversion by choosing sampledocument.csv. Click Open to proceed. Click on the Output Folder button to choose where to save your converted files. Ensure the correct folder is selected for saving the Excel file, then click Select Folder. This time, select only the Excel checkbox, and then click the Start Conversions button to begin. The highlighted area confirms that the CSV to Excel conversion completed successfully. This is the content of the Excel spreadsheet generated by converting the CSV file. The image in this step shows the raw CSV file, allowing you to compare it with the converted values in the subsequent steps. Congratulations on successfully completing this tutorial. Thank you for watching and learning with us.